Hi, hello, and welcome to Washing Maths Online Academy. My name is Desmond Washing. In today's lesson, we are going to do the sets. We are going to do the sets for grade 11 and 12. This is applicable for grade 11 and 12. Remember the previous video under exponent and sets, we only covered mostly the exponent part of it. The sets was not accommodated. So in today's lesson, we are doing the sets. More especially, one of the followers or subscribers did recommend that we should cover the sets. So now in response to that comment, today I'm doing the sets. Make sure you stay tuned as we are going to cover everything that is set related, all the tricks, everything, even some part of the exam questions, how they ask question in the examination. All right, now if you check, I try to divide into sections where number one, we are going to deal with adding of sets. We need to know what is happening actually when we add sets, and then when you're multiplying the sets, I also accommodate part where we simplify the sets. When we divide the sets, which is basically almost the same as when we rationalize the denominator. As you can see, they are in a fraction form. These two, they interlink. Then the last part, I'm going to try to do the exam part. How do they ask questions in examination? Now, what is a set? Talking about sets, expression that consists of a square root. Basically, when you mention the word sets, you must think of a square root. When you talk about sets, think of a square root. For example, I may say this, it is a set simply because of it consists of a square root. We come across most instruction in mathematics where you are asked to leave your answer in a set form. That means make sure your answer, your final answer, must have a root, just to comply with the instruction when they say leave your answer in a set form. So now that's what we are going to do. We are dealing with the sets, which is anything that has a square root. I'm sure if by the look of things from where you are, most problem here consists of a root. Check there, A, B, C. We do have roots. All these square roots is still part of the set. Here we've got roots everywhere. So it shows that sets basically they are referring to the roots. So we're going to tackle anything sets related. We'll start here. The first one is adding of sets. This is where most learners do a lot of mistakes, which we consider to be misconception. We've got a square root of 2 and we must add square root of 3. Consider this. When adding sets, you must think of like terms of variables. If what we have inside the square root is not the same, then they are not like terms. We cannot add that together. Let me take you back. If we have 2x plus 3x, they are like terms. These variables are similar. So we're going to say 2 plus 3 is going to be 5x. So I'm taking you back. Now let's come here. We know there is a coefficient of 1 here. There is another coefficient of 1. But the thing is, like, these are not like terms. They are not the same. So in this case, I cannot say square root of 3 plus square root of 2 plus square root of 3 cannot be a square root of 5. This is wrong on many levels. Square root of 2 plus square root of 3 are not equals to square root of 5, simply because of they are not like terms. That is misconception. So if you come across this, considering these are not the same, what will be your answer? The very same thing, it is your answer. Square root of 2 plus square root of 3, it's equal to square root of 2 plus square root of 3. It remain like that. It remain the same. It's like water and oil. They don't mix. Now, this, it's wrong. It's misconception. Just like when we say, what is x plus y? It will remain as x plus y. Now, that is adding sets. Let's move to the next, which is b. I hope now you can see the difference between the two. Now, in this case, I'm having 5 square root of 3 plus 2 square root of 3. Now, we noticed that now these are the same, which we like to consider as like terms. It's like basically having 5x plus 2x, which will give us 7x. Now, because they are similar, whatever that is inside the square root is similar. Now, you are welcome to add them together. So, this is where I'm going to say 5 plus 2. Then I'll say it's 7. 7 what? 7 square root of 3. These are like terms, but what we applied here is not applicable here at A. Now, with that mentality now, with that knowledge that you have, I would like you to pause and work with the third problem, which is C, and see if you can get it right. Because eventually you're going to move to number 2, which consists of A, B, C, and then we've got 3, only 2 problems based on that 3, 4, 5, and 6. So wherever you are, make sure that you pause the video, attempt solution, so you can compare your solution with mine. And also comment if we've got any, you seek clarity anywhere, or any suggestion of any video that we like us to do. Now, let's come to this one. 1, 2, 3, 4. We've got 4 terms here if you look. But what matters most is the number inside the square root. If they are identical, then they are like terms. I can combine them together like I did with B. But if they're not the same, then there's nothing I can do. Now, let's compare. I have a root of 2 here. It happened that I have another root of 2. You can see. Like I can say this and that. They are the same. Don't forget that this root of 2 has a coefficient of 3. Just like when maybe it is 3x. This is our coefficient. So we are having 3 there. And this side, we've got that invisible y. Now, we consider these as like terms. Even though we are talking sets, they are like terms. Remember, C is a combination of adding or subtract. We can always add or subtract the set. So here it's a combo of both. What about the square root of 3 and 2 square root of 3? Now, let's check that. If you check, I don't have to worry about the coefficient or the number before the root. I'm just considering, check what you have. Square root of 3, square root of 3. I have a 2 here. I have invisible 1 there. I would like to take this as also like terms. My red is failing me. My red marker is failing me. All right. So now I grouped that this blue one, they are actual like terms, and the red one, they're also like terms. So let's just simplify them. I have 3 of square root of 2. However, here I only have 1. What does it mean? 3 minus 1 is 2. 2 what? 2 square root of 2. Just like if it was 3x minus 1x. So yes, the same thing applies. Now here, the red one, I've got square root of 3. 1 square root of 3 minus 2 of them. So because this one is smaller, the answer will be negative. So 1 minus 2 is like negative 1. So I'll have 1 what? 1 square root of 3. That is the solution. If you check carefully, there's nothing I can do here. You cannot take this further and say like 2 minus 1, then you're saying is 1. Considering the fact that 3 and 2, they are not the same. So it's like water and oil. We cannot mix them together. We cannot even simplify any further. Just like the first one here. We left it as it is. We cannot add them together. Here we cannot even subtract. It remains as 2 square root of 2 minus square root of 3. Now, let's move on to number 2. Make sure you watch this video till the end to learn more, because this is where I'm trying to summarize what is important when you're talking about the sets. However, as indicated that this is for grade 11 and 12, but we don't limit. Even grade 10, as they're going to the next grade, they will come across that. It's important for them to know. All right, now let's check. We are dealing with multiplying sets. When you multiply sets, consider this. I have to check the number inside the square root. I can multiply the numbers inside the square root, meaning what is 2 times 3? It gives us a 6. However, because they both have a square root, I'm still going to put them inside the square root. The only thing that I can do, if this number was a perfect square, I was going to proceed with it, simplify even further. But I don't have a square root of 6, otherwise you're going to experience decimal. Remember, we are talking sets. We can leave it as it is. Actually, not we can. We should leave it as it is. Because I don't have a square root of 6. 6 is not a perfect square. Let's check B. Just like here, we said 2 times 3 is 6, and when you put a square root. Here we can say 2 times 8 is going to give us 16. But you must still put that square root. Now, the difference between A and B, 16 is a perfect square, but 6 is not. We left it as it is. But this one, we are forced to take it further. What is the square root of 16? It's 4. Now, you can compare between the two. You can pause the video and do the next one. Don't wait for me to reach to the final one. Now, if you look at C, 2C is almost the same as A and B. The same as A and B. Now, the trick is that A, we were multiplying two different numbers, meaning they are not the same. These numbers are not the same, but here they are the same. If they are the same, the shorter way of this, we know the answer will just be 3. Since it's 3, 3, and inside the root, the answer will be 3 if they are the same. But that is like a short way. But still applying what we did here, we will say 3 times 3, it's 9. Now, what is square root of 9? Is 3. It means, in short, if you're having same number, the answer is that number itself. If you're having the same number inside the square root, especially that we are multiplying, the answer will be just that number. But it is proven to say 3 times 3 is square root of 9, and the square root of 9 is 3. So we don't want to do the shortcut, but I'm just saying in passing. Now, let's come to 3a. We simplify here. This is what you can get also in exam. We simplify. Number 3, we simplify. It means with the knowledge that we already obtained from these first two problems, now we want to see something. In most cases, when they say leave your answer in a set form, learners will just punch a calculator and get to the answer. But we don't want that. We will never ask you to simplify knowing that you're going to rely on a calculator. We need steps. We need method. That shows understanding. So what do we do in this case? Look for factors of 50. Two numbers that when you multiply them together, they give you 50. However, those two numbers, one of them must be a perfect square. Get this. 50 can be 10 times 5. Still inside the square root, it will give us 50. We can also have, I'll say 25 times 2. Now I have two options, even if maybe we can have more, but just to save time, I have two options. But when you check, we are looking for the one that has a perfect square. Perfect square means we can get a square root of that number. So do we have a square root of 10? No, we're going to get a decimal. 5? No. But between 25 times 2, we are getting 50. Even 10 times 5, we are getting 50. But 5 is a perfect square. Now I'm going to take this to say, okay, what makes 50? It's actually 25 times 2. Look for one of the number which is a perfect square. Just like here, the perfect square was 16, which gives us 4. 9 is a perfect square because we have a 3. Now, what does this mean? We can separate this. We can always separate. They is still shared, just like here. They were split, but we combine. Here, they were like almost combined, we split. Now, separately, so we can say, what is square root of 25? It's 5. What is square root of 2? It doesn't, we don't have that. So we leave it. This is when we leave your answer in a set form. 5 square root of 2. Avoid to use the calculator. Avoid to use the calculator. Now let's come to B. With B, if you check, same thing that we applied here. Look for factors of 20, where one of them is a perfect square. We know learners will think that, okay, let me clear the board first so I can have enough space. In the meantime, you can pause and try to work out on other solution. Now, let's check. We are here now. 20, square root of 20 plus that of 45. Now, following the same method, I'm looking for factors of 20. So 20 is made of 10 times 2, 5 times 4. And then obviously, this is not a perfect square, it's not a perfect square, it's not a perfect square. This is a perfect square. So I can use this set. So I can say 5 times 5 times 4. I'm still going to put this. What about 45? Same, when I look at the factors of 45, where one of them is a perfect, I'm having a 9 times 5, which will give me 45. Now, if you check 4 and 9, they're both perfect square. So if we separate, I'm having the square root of 5, square root of 4. Why do I do this? Because they're still under one root. So meaning we can just split them separately. So even here, square root of 9 times square root of 5. Now, give us the result. 5 doesn't have a square root. What is the square root of 4? It's 2. So 2 must come in front. So I'm going to say 2, but square root of 5, we don't have. We avoid decimal. Because learners, they can say, why we say we don't have? It's not a perfect square. So we leave it like that. Otherwise, you're going to get decimal answers. And then while we are talking sets, we don't need decimal. Leave it as it is. Now, what is the square root of 9? We are having 3. 5 doesn't have, so we leave it like that. Now, you remember the first one that we started with? Under adding. When we're adding roots that are similar, we consider them like terms. So I'm having 2 square root of 5 plus 3 square root of 5. Consider it as 2x plus 3x. That's going to be 5 root. You leave it like this. This is the set. We leave it as it is. So that was our B. Meaning, let's move to number 4. Dividing sets. Number 4, this is where we are dealing with dividing of sets. Basically, when we say divide sets, we experience a fraction where our numerator is square root of 8 and denominator is square root of 2. In this case, we can say rationalize the denominator. But hence, I indicated it here on number 5. So I want to show you that I can apply a different method and here also show you how to rationalize the denominator. So a different method here, we'll say, now, let us split 8. What are factors of 8 where one of them is a perfect square? 8 is made of 4 times 2 over square root of 2. Therefore, we split. It's going to be square root of 2 times, square root of 4 times square root of 2 over square root of 2. If you check something, I notice that we have same. These are similar. As long as there's a multiplication between, we can cancel what is similar. What does this mean? I'm left with square root of 4. And what is square root of 4? Is 2. That is the answer. Somebody can apply a different, you can apply rationalising to on this one. You're still going to get the same answer. Of which I can also try to work on it. So let me clear the board from here to show alternative method. to show alternative method. I didn't charge my phone. Now I have to rush because I can see the battery. It's not looking good. All right. Now, you must make sure you follow me thoroughly. I do number 4 again. Number 4, I do a different method of rationalize. I'm now rationalizing this. What does rationalizing mean? Meaning, do not leave your answer, your final answer, with a denominator that is a set form. Meaning, I don't want to see the denominator consisting of roots. So when you say rationalize the denominator, we try to get rid of that square root as a denominator. So what do? We multiply by this denominator twice. This is us rationalizing the denominator. Now, if you remember what we did previously, where we were multiplying sets, 8 times 2, that's 16, but still inside the square root. We had something of this nature as well. When I said if they are the same, obviously it will end with that number as a final answer, meaning 2 times 2, it will be square root of 4. You take it further, it's becoming 2. But we avoid shortcut. What is 2 times 2? That's 4. Now, if you proceed, both numbers are perfect square. Remember, I'm rationalizing the units, applying the second method from what we did there. Now, what is square root of 16? It's 4. What is square root of 4? It's 2. What is 2 into 4? It's still 2. You say, we rationalize the denominator. My answer doesn't have a denominator that is actually a root. Remember, the denominator of this one is like that invisible one. But if you check, answers are the same. Method, different. Okay? Now, let's come to number 5. I'll bring number 5 right here. If you check number 5 and 4, almost the same. But here I just say dividing sets. While we know we can still apply rationalizing denominator method. Here, I can still apply the rationalizing denominator because I can apply this method here. As you can see, we cannot change 3, even a 5. We can't. It's already in the simplest form, unless if this 5 was another number. So in this case, I'm forced to rationalize the number, meaning let me multiply by square root of 5. And we always do this. Whatever number that you have, you multiply the same number, both side numerator and denominator. And then don't say, now why don't you just cancel? No, otherwise you didn't do anything. Hence, rationalize a denominator. We don't want our answer that has a denominator with as a set. Let not our denominator become a set. Get rid of a set from the denominator. By so doing, you are rationalizing a denominator. Let me proceed. What is 3 times square root of 5? You just bring them closer. There's nothing you can do. But we come across this more often, just like what you did here. When numbers are the same, yes, even if they differ, we multiply what is inside the square root, but still put your square root. So 5 times 5, that's 25, but still inside the square root. The aim of rationalizing the denominator is to get rid of that square root. Now, my numerator, there's nothing I can do, but my denominator, 25, is a perfect square. What is the square root of 25? It's 5. You see, I achieved, because now I managed to get rid of the root. I'm now having a 5. It ends there. Finish. Please, on the comment section, if you want to know more about sets, you are welcome to say so. Just let me know. As it is suggested by one of the subscribers, it will suggest if you can work on the set. Now, this is me trying to respond to that. Now, let's work out number 6. Number 6, I think it's the last one. It summarizes what we actually trying to achieve. All right. Let me bring it here for everyone to see. Number 6, simplify. You know, in the exam, they like to just say simplify, but they don't even explain. They just say simplify. We know that. So I'm saying simplify exam. This is from the exam. I took it from one of the paper. So we've got, let me start with B. Because as you can see, A is like difference of two squares. If you see A is a difference of two squares of some sort. Because we've got same thing here, just that is a plus or minus. That is part of difference of two squares. So let me start with B. Here learners, they are very much aware that they are dealing with finding the product, like FOIL. This is where you apply FOIL. No matter we are talking sets. Remember FOIL, first, outer, inner, last. This is you saying, okay, because I should not assume that everybody knows. When you say FOIL, first term, we multiply the first term together. From then outer, the outer terms. This one is the outer term of the first bracket, but this is the outer term of the second. So I must also multiply that. Then the inner, these two, they are the innermost. They are within, they're inside. If these are out, these are in. Then the last. One is the last term of the second term. However, minus 12 is the last term of the first term. So I hope you understand that. All right. Now, remember we started by adding sets, multiplying sets, dividing sets. Now, in this case, everything that we did previously come in handy. We have to apply that. Now, let's do baby steps. 3 times 2, that is 6. Square root of 2 times square root of 2. We said, as long as we are multiplying two square roots, we are focusing on the number within. So square root of 2 times 2, that's a 4, but inside the square root. Somebody will simplify right away to say, now the square root of 4 is actually 2. And that 2 times 6 is going to be 12. But now, let us not rush. We still follow what we did previously. Now, I'm done with this one to say 3 times 2 is 6. And then 2 times square root of 2 times square root of 2 is like square root of 4. Then again, this 3 square root of 2 will multiply by 1. It's going to be a positive 3 square root of 2. Now, I'm done with the first two. Now, coming this side. Minus 12 times 2. That is minus 24. Square root of 2. Obviously, this times that. Only this, the coefficient of square root of 12 and the 2 will multiply together. Now, again, minus 12 times positive 1. That is minus 12. Just like when you're doing the quadratic where we experience trinomial, blah, blah, grouping, the same thing. Now, if you check, it's always the case that the center ones are the like terms which need to be grouped together. So if it's 3 minus 24, we have to find the answer for that. So that's going to be a minus 21 square root of 2 minus 12. And then I'm having this. Now, this time, that's when you say, why this square root of 4 is 2. So what is 6 times 2? That is a 12 minus 21 square root of 2 minus 12. If no mistake, it means now what we're having is like 12 minus 12. It means they cancel. So now I'm having a negative 21 square root of 2. There's nothing I can do from here furthermore. So it ends there. So we can verify if there's a mistake somewhere, but I don't think there is a mistake because obviously 3 minus 24 is going to be minus 21. However, these are like terms, just like previously when you say square root of 2 plus square root of 2, that is 2 square root of 2. We are combining the two. Same applies here. So this is where the first part come in handy. And then here we know that I said if you are multiplying same number, the answer will be that number. If you can check square root of 2 times square root of 2, the answer is 2. But I didn't just want to jump. I said you can also say 2 times 2 is 4, but it's still within the root. And then from then, that's when you say since 4 is a perfect square, what is square root of 4? It becomes a 2. Then you simplify. Now let's go to A. Let's go to A. Now let's do A. Here is A. Let me just here. Let me clear the board for you. Now make sure you subscribe for more videos to follow. Imagine for now it's just term. We are just in the first term of the year, and this is February. So imagine the whole year, things that we're gonna upload here. It's almost the entire syllabus. So make sure you subscribe, comment, because you can also let us know what is it that you want us to present. we're gonna do that. Okay, let's move to the next part, which is the last one. It's number 6a, which we skipped. All right, if you check A, it says square root of 7 plus square root of 6 and square root of 7 again minus square root of 6. It doesn't change that. We are still going to apply 4. But hence I say we experience a positive and negative and everything is the same. I said it's going to be a difference of 2 squares, meaning the middle term will cancel each other. Just like the previous one, the middle term, they added together until we get a minus 21. So in this case, it will be different. Now, check again, 4 doesn't change that. By now, you know what is 4. So I said we start 7 times 7. That is 49, but it's still within the root. But the next part, that's when you say, what is the square root of 49? So we'll do that on the next step. Remember, we teach to make sure you understand. The more we skip steps, some learners, they really like being thrown out. They actually become a victim of failing, not understanding. All right, now let's check. Now again, square root of 7 times square root of 6. So basically, when we say square root of 7 times square root of 6, I want to make sure so you understand exactly what is it that we are. I said we still stick to when we say square root of 7 times square root of 6. I'm concerned about the numbers inside. 7 times 6, that will be 42, but within the square root. And then obviously it's a negative because positive number and a negative number, it gives us a negative. 7 times 7 is 42, but it's still within the square root. Now I'm done with the top coming down. I have a positive square root of 6 times a positive. So I'm going to express a positive there, but it doesn't change what is square root of 6 times square root of 7. That is still 42, but it's still within the root. Now the last part, positive times negative, that's a negative. Square root of, square root of 6 times square root of 6. We're going to say 6 times 6 is what? Is 36, but still we put that. I didn't skip any step from here. Now, if possibly we have a perfect square, we simplify. If not, we leave it. But we do have 49, which is the square root of 49, it's 7. Now look at this. Square root of 42 minus square root of 42. Because they are the same, then they don't exist anymore. Minus, what is square root of 36? Is actually a 6, because 36 is a perfect square. So now it leads to 7 minus 6, which the answer is equals to 1. Now, if you want more of this, can be any topic that we are going to do, please subscribe and hit the notification bell so you can be notified every time when we upload a new video. Like and share. So if you want more of this, make sure you stay tuned, you follow our channel, and let others know about this channel. Those who don't know, make sure you share. I thank you. See you on the next video.